Okay, it's 4:10. Good afternoon again. My name is Vineet Tyagi. I'm the CTO for Impetus Technologies. We've been helping Fortune 100, 1,500 enterprise customers deal with big data challenges and use big data for business benefit for almost 10 years now. When I say 10 years, the question that probably pops up in your mind is, well, Hadoop's not been around for 10 years. What were you doing earlier? And that's a valid question. We have been, since 2007, we've been working and helping customers analyze large sets of data in Hadoop's infancy days. So we've been associated with Hadoop and helping customers derive business value with big data. And I'd like to thank all of you for taking time off and making the choice to come to this session. I realize that the topic would be something that interests you. I'll try my best to share our experiences that we've had working with customers and try to share that with you such that that you can benefit from it. And since we don't have a large turnout today, I'll focus mostly on the slides, but if you have any questions, feel free. That would be the best use of all of your time as well. So let's begin. What I'm going to talk about is some of the critical trends, and as my topic suggested, swimming across the data lake, right? How do you really benefit from the data lake? So what are some of the critical trends and the lessons we have learned from them? Based on our experiences, we have created a repeatable methodology and a framework that we call the dilemma framework. And I'll talk more about that. I'll touch upon aspects of data democratization, enterprise metadata management, data access, self-service BI, and migrating workloads. And I'll also talk about, towards the end, methodology and a framework that allows lift and shift to happen in a very automated fashion, and some challenges associated with that as well. So let's, before we start, I just wanted to take a pause here and let's take a step back 2-3 years ago. What were people saying in the first or the second Hadoop Summit? 2013 or 14 was the first Hadoop Summit. I don't exactly remember whether it was 14 or 13, but at that point in time, most of the big data projects were failing. There was a lot of problems in the big data ecosystem itself, and early customers were facing tremendous challenges. 2014 was the year that Gartner put out Hadoop as a technology in their hype cycle. Fast forward, the problems started disappearing, the stack started maturing, and in 2015, this was the fastest technology, one of the fastest technologies to get out of the Gartner hype cycle to become real. Businesses started realizing benefit in 2015. This is the state of the union. At the Gartner BI Summit in March, Gartner put out the results of their BI survey, the yearly BI survey that they do across thousands of small, big, medium enterprise customers. And they said that enterprises today are only realizing 15 cents worth of value for every dollar they're investing in their BI infrastructure. And that's a lot of money going down the drain. 85 cents for every dollar that is being invested in BI is not resulting in business benefit and value. So how do we deal with that? So having been helping our customers, what we've realized is that the increase in the ROI on the BI expenditure is primarily being driven by a modern data architecture now. And that seems to be the way forward, and everybody seems to be aligned that it is increasing their ROI. So what does this modern data architecture look like, right? This is not, it's not down in the details with enough technology details and choices at all, but at least across 20-25 customers I've worked with them, I've seen this is by far the most successful high-level blueprint of what everybody is doing, right? And what everybody doing is actually very simple. You're dealing with different types of data. You have streaming sources of data. You have structured, unstructured sources of data. You have machine, geospatial, time series kind of data. and external, third-party, social, and other sources of data that are coming into the enterprise. The enterprise has to learn to deal with them in a most cost-effective fashion, and the traditional data warehouses are choking. They're not geared up either on the capacity or the capability or the cost front to handle these newer forms of data. So what is happening is Hadoop is playing a good role in creating the landing and ingestion. That's one pattern that we've seen people have been successful in. People are using tools like Stream Analytics, Storm, Kafka, their own homegrown solutions to create real-time applications to bring more deeper insights into data or with data as it comes into the enterprise and take more action closer to the data as it happens. Then there is these traditional data repositories. They're not going anywhere. Maybe in the long term they will disappear or not. That's for future to see. And we shall see that what happens with that. But Hadoop is coming up as a credible data repository which coexists within the enterprise as an adjunct warehouse to other data repositories that are there. So now the enterprise is transforming because earlier there was only the traditional data repositories were there. Now Hadoop is playing a credible role in the ingestion, landing and ingestion side. And it is also providing an enterprise data lake capacity, storage capacity where deeper analytics and deeper insights can happen. Now how this is transforming the enterprise is now they have to deal with governance, they have to deal with data security, they have to deal with monitoring, they have to deal with information lifecycle management, metadata management at a very different scale than they used to deal with earlier. And primarily what they were dealing with was structured data. Now with Hadoop, there is more unstructured aspects of data management coming in. So all of these needs to be expanded and transformed such that the business users get benefit out of it. And on the other side of it, enterprise applications are deriving benefits from this new logical architecture that enterprises have, in which Hadoop is playing a critical role. Exploration and discovery for machine learning, analytics is playing a critical role. And so are predictive applications becoming the norm in the enterprise as well. So with this blueprint in mind, this is what we've seen at our customers that most of them are doing. One of the easiest thing that happens is that enterprises are mastering the landing and ingestion side of data. And if I poll, many of you would put up your hands and say that's something that we've taken care of. We know how to land and ingest data. I think majority of you would agree with me that's a problem that Hadoop solves really well for data accumulation perspective. Now the problem gets complicated when business users, so you have a lot of data you accumulate as an IT team, you present it, maybe through Hive, HBase or whatever mechanisms to your business users, and business users don't know what to do with it. And that's the number one challenge that's happening today in the enterprise world. That we are throwing our users into the data lake without equipping them enough to know or enabling them enough with the knowledge of how they can swim across the data lake. So creating of the data lake is just the beginning, is what I'm trying to say here. Okay. So how do we create a data lake and a set of swimmers, expert business swimmers who swim across the data lake? That's the dilemma that we're trying to solve, and that's what we've codified. So dilemma actually is, how do you transform the data lake into something which derives tremendous or delivers tremendous business value for the business users. We've seen if we solve these aspects, solve these aspects of data management, ingestion, storage, governance, security, if we solve the information lifecycle management, including the lineage and audit aspects, enterprise metadata management, including the discovery and ontology aspects, and have access, different types of access enabled over the lake that has the right kind of query performance for the right kind of use case and allows users to search the data and reach it, you would pretty much have solved and taken care of majority of the enterprise business users' problems. So let me share more insights into what our framework is and how do we go about solving some of these challenges. Now, before that, I'm going to be sharing some of the trends with you, what industry analysts and some of the leading websites and data experts are saying. What Gartner is predicting, and unfortunately, this is a very recent prediction they've done based on the state of the big data BI infrastructure that they've seen. They're saying that by 2018, which is not too far, 90% of the data lakes that enterprises are creating will be overwhelmed with information assets captured for uncertain use cases. So what they're saying in a nutshell is you will have a data lake, which is a data swamp, which is basically useless. Now that's an end state none of us want to be in, right? Now how do we deal with this? How do we plan for success? How do we make sure that we are not in the Gartner prediction and we are not the ones whose data lakes are becoming the data swamps? From experience, I can share all our customers who have successfully dealt with this problem have dealt with one fundamental aspect being done really well, and that is to make the insights and data in the lake readily discoverable, accessible, and usable. It's very simple to state that, but in effect, what are the kind of activities that will enable this to happen? How will we orchestrate that our data lake architecture, the modern data architecture, becomes enabled enough to do this? So what we've been seeing is that doesn't work like this. Okay, it works like this. So what we're saying is that the best way to handle the D part of it in the dilemma framework, all the data-related problems, is to actually create self-service discovery, kind of have the data democratization paradigm available for the users. So data discovery is something that's very fundamental to the success of the business users. It's fundamental to the success of the IT teams who are enabling and building the data lake as well. So we don't have to tell the business users what they need. That paradigm is not going to work with the data lake paradigm. That's the old paradigm. What we have to do is we have to help the stakeholders, we have to help the business users and the users of the data lake find what works best for them. So discovery is something that's very critical to the success of the data lake. And how would we do it? Some of the things that we design for and deliver on. Now there's no one solution that I can recommend, or a tool or a set of technology that I can recommend, that I can name also that solves this problem. But what I'm sharing with you are best practices and patterns that we have either implemented by leveraging technologies that exist in the open source, or by enhancing them, or by building solutions which address these components. Okay? So some of the best practices that have worked for us: identification of unknown data. Now if you're hydrating your lake through some data sources where the data is unknown, you just don't know what the data is, it's some data, and you put it there, your users will not be able to use it. So that's something that you will have to work on in making your data smart, and making sure that every element of the data that hydrates the data lake has metadata and tag or some kind of tagging associated with it, such that it can be identified for future use. There has to be a consolidation of the enterprise data dictionary. There has to be something that describes what is available in the enterprise, what data assets are there. And it kind of overlaps with the enterprise data metadata management aspect as well. And we'll talk about that in a little bit more detail later. And metadata has to be captured through the life cycle. Many times it's a myth that if you capture the meta information at the ingest time, you've done it and you know what is there. But what will happen in a data lake eventually is you will bring data sources in, you'll store them. There'll be IT and business users who will start working and deriving data sets out of it. And pretty soon you will have derived data sets which do not trace back or do not have any kind of meta information to describe what they are and what they could be used for. You need some kind of search capability that will allow users to find what they need. On that metadata, they can do a Google-like search or keyword search or some fashion, some visual discovery paradigm that will enable them to find what they're looking for. You obviously need to bring in tools or some kind of capability that will allow them to browse and sample the data, see what it means. what the structure like, and get some familiarity with that. And collaboration tools for sharing their insights and bringing the whole data democratization paradigm into play. The next step towards democratization, towards a full data democratization, is making sure business users and the users of the lake have full data accessibility. That not only lowers the barrier of adoption for the different stakeholders, but what it in a sense means is that the operation of accessing data should be governed, but the governance should not make getting to the data a slow and an iterative process. Like, I have to submit something, I have to wait for a few weeks to get access to it. I didn't get access to everything I wanted, so I go back and I request for something. It takes another few weeks, and then, even if weeks you replace by days, it's still not going to work. So what have we seen that works? We've seen that easy to use access request mechanism, some kind of a monitored approval workflow system that you can bring in. And when one of our customers, what we've seen is that a data discovery which was built on metadata as a search capability, users could fully discover what's available, and but they didn't have access to the data sources and the data sets. It was governed. So if they found something they wanted to use, they would just go and say, okay, I'm putting in a request for this data. The workflow engine would find the right stewards to look at those requests, and they would approve or disapprove, or they would enter into some kind of a collaboration, negotiation, conversation, and based on that, which either users would have access to that data or not have access to data. But all of that happens in a timely fashion and is monitored. The next level, the phase 2 of this could be that based on the experiences, we could automate this workflow. We could bring in, and we are bringing in, certain level of automation and decisioning, which is built on rules which says, okay, if you're this and if you're this, and this is what you're requesting for based on your roles on this data set, you should get access to that. Or maybe because this prior request was declined for this reason, you belong to the same department, and hence you should not also get access to that data. So there can be fast decisioning, business rules-based decisioning, based automation that can be brought in. The other aspect of data accessibility is also tied to the ingestion. Many a times what we've seen are in real life situations with data lakes, what happens is, as business users are building use cases and working with data, they discover that they can enrich what they are working on with newer sources of data sets which may not be present in the lake. So they need a mechanism for fast ingest, fast provisioning of data, and that has to be integrated into the same request approval mechanism and workflow that I was talking about earlier. The best would be if there are automated data provisioning mechanisms, self-service data provisioning mechanisms, data blenders which are out there that can allow users to do their own data blending and have access to newer data sets. The end goal for solving the D part of it, which is the data related part of the dilemma framework, is that you have to make sure that we get the most out of our data lake. And how do we get that? Is by making it simple to use. What that means is that you have to virtualize the access or the data views in some fashion that hides the complexity of storage. We've seen at one customer, they were struggling. What they had done was they created an absolutely phenomenal piece of ingestion mechanism where they were acquiring tens of terabytes of data in a Hadoop landing zone. They were putting it in Hive, and they were making it available in HBase. And for 3 months, 4 months, 6 months, they were scratching their heads and, we've done everything, we've got you the data, now why don't you use it? It was not easy. So the platform, just because it's there, your business users don't know HiveQL, they don't know how to use it, HBase is not enough for them. So there has to be some tooling and mechanisms that abstracts this the complexity of going to the right platform and the right query engine and hides this complexity from users. So what I'm saying is provide some kind of business user-friendly tooling and facades to technical tools that can help them consume this data. And I'll talk about a little later about self-service BI capability over the lake. So that should help users visualize the data that exists in the lake as well. It has also worked that if once at a certain level, business users relate the data sets more natively to the business entities and the business, rather than just the tables and structures and files and formats that exist in the HDFS. So if we build an ability to link the data views to business entities, that definitely helps the adoption and the accessibility of the data as well. You know, if you can tie up successfully the lake and publish it to the tools that are being used, you know, BI tools that are being used, it definitely helps the users access the data lake through familiar paradigms as well. Data science is emerging as a new way of working. You know, every business team is either working with data scientists today or bringing in data science capabilities through building that newly, or contracting, or hiring through other help, or bringing in tools that helps it easier for them. So what really has worked is if you have ability to wrap the complexity of the analytical machine learning or the analytical algorithmic processing, abstract that and provide that to the end users. The end users do not understand how this scoring algorithm is based on some segment analysis and some categorization and, you know, other you know, type of algorithms. What they recognize is that I have either a recommendation block, or I have a capability that will allow me to reach certain customers and whatnot. So if you can wrap these into something that's very familiar for them, they would be, you know, they end up using it in a much better way. I also spoke about, so we covered the D part of it and the IL part of it, the information lifecycle management of ingesting data, handling, you know, customers' view, etc. So the EMM part of it, the enterprise metadata management, that's becoming a more critical. It has, you know, traditionally been, even with traditional data warehouses, been a critical way. We used to have our MDM solutions, we used to have our other metadata management solutions. But how it's getting complicated is that the fact that with big data there is more schema on read, right? The more schema on read you build, and the more types of data assets which have schema on read you bring into the data lakes, the more complex it becomes, right? So there needs to be some description. Now, how many companies are handling this, and I disagree with that, by the way, is that they're trying to enforce structure on unstructured data. So they're trying to enforce either a relational structure, they're trying to enforce some kind of a structure that will describe the data. So you're basically putting a structure on a data that should not have structure. So the whole benefit of schema on read that accrues from, you know, rapidly ingesting data in a data lake and having ability to work with different types of data sources goes for a toss. Now the way to do it is that we should have a enterprise-wide metadata management capability, right? If you go back to the blueprint that we had on the screen about 15 minutes ago, you would recall there were traditional data warehouses, there was the Hadoop-driven data lake, and there was ingestion zones, and there was a bunch of other capabilities, right? So there has to be a capability that has to be built for success that will allow for automated schema ingestion from across these enterprise data sources. And then you can build a data dictionary or a data catalog out of this information. Now that becomes one logical metadata view that every customer of yours can go from the data lake and can find out what exists across the enterprise. They can search anything. They can do a keyword Google-like search. If they go and search for customer, for example, it should have the ability to tell you that there is a customer data set about transactions, which is about 3 months worth, that's there on the Teradata repository. It should be able to tell you that I do have customer transactions for the last 7 years in the Hadoop archive, and these are the set of transformations which may be HiveQLs or analytical algorithms that people have created, and what do these transformations do for you. If you're able to build a capable discovery tool like that, we've seen that business users just love it and they fall in love with the data lake paradigm. Obviously, it have to be incrementally updated, and there has to be some automated meta. It's not a one-time job that you created and and then it ends. It has to be in sync. What we've also seen is that once you start building this metadata store, it becomes actually very easy to kind of catalog the entity's life cycle. So you can actually have a data flow that shows you how different business entities or their life cycle occurs during the journey across the enterprise data warehouses, how it gets transformed, what kind of transformation it goes through, what happens, what it morphs into. And for one of our customers, we put a beautiful, simple visualization on top of it, and they just love the fact that they can see the business information flow in a very seamless fashion happening across the enterprise. I think the next level of this, if you want to take it to the next level, is where you can have machine learning algorithms or apply semantic analysis or other technologies for unstructured data to describe itself. So what it basically means is you have machine learning and other aspects figuring out from unstructured data as it comes into the lake what this could be, what it might describe, and what its data type it might be. And that goes into some kind of an approval workflow where domain experts can analyze it, approve it, say this is correct, this is wrong, this is not what it's supposed to mean. And this learning is a continuous process from the enterprise metadata management perspective. Now that brings me to the last part of the dilemma framework, which is how do you access the big data? I'm sure during the last 3 days at the summit, you would have heard about many of the engines, query engines which are out there, and they would be vying for your attention, and they would be proposing that they are the best engine and the only engine that you should work with. I think that's not what you should be doing. What we have learned from experience working with different customers is, as yet, you do not have one engine that will solve all your use cases. What we have found out is that once you get the data in the data lake and it resides within the data lake, there are different contexts of accessing the data. And each of that context, the business use cases, requires a different type of data access pattern to be implemented. So what we recommend to our customers, and we've been very successful in implementing this data access strategy, is that don't bring in one query engine, bring the right query engine for the right context and the use cases. And what we found is there are not that many. If you have a very specific query and reporting need, you need a very fast SQL over the big data lake. If you have cross-dimensional fast slice and dice and drill down kind of analytical processing that you need to do over hundreds of terabytes of data, let's say, you need an OLAP kind of engine that will help you. If you need to virtualize, basically access data between different data sources that exist across the enterprise data warehouse, you need to have a data virtualization capability that's built in. If you're literally, the use case is finding, or the pattern is finding the needle in the haystack, you don't know, the IT teams or business users don't know what is there, search kind of capabilities are what we should be building for. And then there is, I don't know, and I don't even know what I want to know. So I don't know what you want to find out. So these kind of capabilities really need self-service data discovery capabilities. And why this is a little distinct from the search capability is because what you don't know sometimes also means that you have to ingest some other data sources to then provision that data and then try to find some more meaning with the data, right? So it's a whole discovery capability that needs to be provisioned and built. These 5 patterns by far covers pretty much all the enterprise use cases, and all of them require different capabilities of access to be built into the data lake, is what we found. And to success, if you really want to swim across the data lake, make it easy, this is what you should strive and implement for. Now you can begin with whichever one covers most of your use cases. Like if you primarily have specific query and reporting to be done out of data lake, you should go for the best SQL engine. If you have cross-dimensional fast slice and dice, you should go for a good OLAP engine. And the beginning can be any, but eventually as an enterprise smart data management and data service platform, primarily data service platform, your data lake needs to support all 5 of these patterns. Another critical trend that we've seen is self-service BI over data lake. Gartner is predicting that by next year end, most of the enterprises will have some shape or fashion a self-service BI capability. And Forrester is predicting that managed BI self-service will continue to close the gap between business and technology. So that traditional battle of business versus technology and IT is getting bridged more and more with the help of self-service BI. And it becomes effective that your data lake strategy has to include self-service BI capabilities. This is our, we call it the self-service BI capability worm that has to flow through the data fabric such that you have a very effective self-service capability. So what this means is basically that it's not just having the ability to ingest data at scale, and that's the be-all and beginning of all, and that's the end of all. And that's giving good tools, usable tools to users to create some BI capability over top of that. Self-service BI requires a more seamless integration of having the cluster provisioning down to ingesting and transforming data on a repeatable basis. So all these aspects of BI capabilities have to be in self-service mode. So there has to be some self-service way of provisioning clusters, ingesting and transforming data, discovering and blending new sources, security and governance on the new data sources you're bringing in should be applied on that. The data access and exploration should happen in some, and eventually the BI analytics and model development should happen in a self-service fashion. So self-service BI is not only about the BI analytics and model happening in self-service fashion, but all of this as precursor activities also being available as through a self-service mode. And that's extremely critical for success again. If you remember, I began with the blueprint of the modern data warehouse or the modern data architecture. We have also realized through some of our mature customers, meaning that some of our customers have been doing big data since 2011. They're a little ahead in the game of how they have evolved and matured their data management infrastructure. There's a fundamental capability that mature big data lake initiatives would need, and that is the acceleration to move workloads between traditional data repositories and in the enterprise data lake. What this means is that as you grow more and more and throw more and more data and build more muscle in the enterprise data lake, you are actually building a capability that allows you to then take a distinct decision on a cost and performance basis, price performance of where should I be running the workloads. Now, traditional data warehouses are good at doing lots of things. They were engineered, they've been perfected over 20 years, and you don't want to throw the baby with the bathwater just because we get a new data lake in town and let's just get rid of all the other things. But they're good at certain things, and Hadoop is very good at certain things too. You can run certain workloads on Hadoop, and you can transfer them over from the where they're existing today. And this is a capability, most of the people refer to this as lift and shift or fork and drop or whatever different names they use. So having an acceleration of the lift and shift would allow you to very quickly take these decisions of where should I run my workloads based on the price performance I'm looking for. And why are some of our customers migrating these workloads to Hadoop? What we've seen is that it frees up capacity to contain costs. So one of our customers is asking us to replace 40% or free up 40% of their Teradata capacity and move that over to Hadoop. And 40% of storage and I/O and compute capacity on a Teradata cluster makes available to their business users what they've been asking for. Teradata's capacity is good for doing certain things, and business users want more of that. Their SLAs are not getting met. So instead of bringing in 40% more Teradata, you actually offload stuff that can happen on Hadoop, and that voila becomes as the next 40% capacity available to your business users. So they're containing cost and containing the expenditure as well on this relational warehouse. They're creating a multi-platform data warehouse environment where workloads are now getting orchestrated and they're running in the best place. They're running where they should be running. And there's a seamless data interchange that's happening, and a true multi-platform modern data architecture is evolving. They're also migrating it because some of the workloads are good for certain cases running in the traditional data warehouses, but they are not fit for doing more advanced analytics with joining the unstructured data, etc. So when you move them to Hadoop, you get a better platform suited for doing the analytics. The problem is that manual migrations are tough to make happen, and they're multi-year, multi-million-dollar. Business logic has to be recoded, debugged, and vetted in a Hadoop, which is a highly risky thing to do. Hadoop skills are in shortage. Not everybody can spin up and invest $2 million in 50 people teams. So that's one of the biggest barriers why people are not even focusing on that. And there are certain challenges as well on the technology side. Hadoop by itself, the technology readiness is not there. Hadoop, HBase, Phoenix over HBase, Hive are not ANSI 2012 compliant. So they fully cannot run some of the stored procedures. They fully cannot take advantage of the SQL workloads which have been running earlier. And then there is the complicated nature of the process. What to offload, what is there, how much data. And these workloads have been written and coded for a huge amount of time. So it really takes a large effort to even decide what should be migrated. We built a framework and a model of automation that allows us to quickly, we call it the 4-click paradigm. It's too late. I cannot offer you to stop by our booth and see a demo, but I hope some of you may have seen the demo. If not, and if you're interested to see how this 4-click really works and make it easy, just let me know, and we'll be happy to set up a WebEx demo for you. So really, we make it easy. We can connect to any of the warehouses. We can assess. We can do a very intelligent assessment of what should be offloaded, what queries, what data, what tables. And then we have a tool set that migrates data, migrates the workload. So we actually have, it's not a manual effort. We actually can take queries, BTEQ queries, Netezza queries, PL/SQL queries, and we can automatically convert them into HiveQL, Spark SQL, or Phoenix over HBase code. So there's no lock-in. We actually convert it to a working Hive SQL. And then we also execute and support the data loading back into the Teradata warehouse. Not only that, we have automation for the validation part. So conversion is one thing. Yes, the code has been converted and the data has been migrated, but functionally, is the workload doing what it was doing on Teradata in the new Hadoop warehouse or not? So we can automate the validation of those aspects as well, plus the SLAs. So come to the end of my talk. So this is the blueprint, and I did share some of the challenges and our frameworks. Now, Impetus has been in the business of helping customers, and based on our learning, best practices, and accelerators that we have developed and tooling we've developed, we make it simple for any enterprise to really gain from the full potential of the data lake architecture, right? And move the needle from losing 85 cents on every dollar that you're investing into your BI infrastructure to actually gaining 85 cents worth of revenue back from every dollar or every penny you are investing. And for that, we have built several tools. From the accelerator I just introduced you, the workload migration. We have, from the landing and ingesting perspective, a very innovative tool called Data Blender that's there that also helps in data wrangling, metadata and discovery. We have data access covered, we have data governance covered. We have a product called Kaiwas Insights that allows us to access and work extremely fast with huge, unimaginable amounts of data sets. And we also have a tool, a visual app building tool and capability that allows us to deliver to customers rapid real-time application building capacities and capabilities. So with that, that's the end of my sharing of the session. Just on time, the clock says about, I'm over time, just in time. I kind of made the clock. But since this was the last session for the day and there's a break between whatever happens next, any questions anybody has, I'll be happy to take that in a minute or so. All right, thank you folks again. I know this is the last session, but I appreciate and thank you all for stopping by and helping me share this. Thank you.